All right, so we are now looking at the example of the size wave frame, and we're going to solve it with the moment distribution. Okay. First and foremost, I have to tell you that I made a mistake in solving this problem long time ago, and I look at it and try to fix it this morning. I ran out of time, so this problem will be solved without this load. Okay. There is no horizontal load, and this uniform load is 3 tons per meter. Okay. Oh, and I also forgot to. Wow, I thought I finished it, and then I forgot this. The moment of inertia here is going to be. Let me change the color as well. 10I. Hope you guys can see it. This is 9I. This is 12I. This is also 9I. And this is 7I. Okay. And I think I need to give it some name. So let's call that A, as usual, B, C, D, E, and F. Okay, so we're gonna take care of the relative stiffness first. So step number 1 is the relative stiffness. Okay, KAB then. KAB is 9I over 9. Rather convenient, right? That's I. And then KBC, it's the same, right? It's also 9I over 9, which is I. Oops. Ah, geez. Moves too far. Where is it now? Okay. Oh, sorry. Was it because I hit the page number, right? Now where were we? Awesome. Okay. KAD is next. Now you can't see the structure. Okay. KAD is 10I over 5, or just 2I. KBE, that's 12I over 6. Nice, huh? 2I again. And the last one is KCF, not KFC, you know. So it's 7I over 3.5. That is also 2I. But you should know that we have the simple n here and there. So I have no hesitation to modify it with the 0.75 for the simple n. You may not use a symmetry because it's complicated, but you know, when you have a simple n, you really should do it. Use it. Okay. So this becomes 1.5I, and that's also 1.5I. So we are down to our distribution factor now. Number 2, this distribution factor. I don't know why I don't write DFs, right? Should be DFs. And now we are going to look at the joint A. So we have distribution factor of member AD versus distribution factor of member AB, right? And Now we have AB and AD. It's between 1I and 1.5I. So the total is 2.5, 1 over 2.5 and 1.5 over 2.5. That's 0.6 versus 0.4, right? That's simple. Okay. And for joint B, we now have distribution factor of member BE of member BA and of member BC. Okay, that's we have 2I and I, so that's 0.5, 0.25 and 0.25, right? Notice that the total summation is always 1. And for distribution factor of member at joint C, it's member CF and member CB. That's 0.6 and 0.4 again. Okay, so we shouldn't have any problem with that. And then fixed end moment. Number 3, fixed end moment. Okay, we have one uniform load, so it's going to be FEM AB. That's going to be equal to minus 3 tons. The span is 9 meters square over 12. And you know, talking about fixed end moment, don't say that I haven't warned you. You know, simple, silly mistakes do happen in homework, and when you think it's funny and it happens to you, it's no longer funny. Okay, so this is minus 20 and a quarter meter, and that's equal to minus FEMBA. So we are quite ready to do the distribution, you know. So let me just switch to good note, and hopefully I can write them down with good order. Okay, here we are. Wow. Okay, I have to use this smaller line, and let's try to establish something in the middle. Oh, black is better. Okay, like that, and perhaps like that, and perhaps like that. Okay, so that's basically our frame. Okay, now I have the distribution factor here, 0.6. And right here is 0.4. Right here is a quarter. Here is also a quarter. And that's 0.5. So you guys know the direction that I am going to write, right? Hopefully. And this is 0.4. And that's another 0.6 here. Okay, and we have the moment equal to minus 20 and a quarter here, and then 20 and a quarter there as our unbalanced moment. So let the fun begin now, right? Wow, can you please do tell me if some numbers are not very legible, like this one, 0.6. and look like 0.6 much. So let me try to fix that. Okay. That's 0.6. Okay. So the first step is just to balance this, right? So let's balance it with the blue color. So right here at this joint, we have unbalance of 20.25. So 25% is going to come from this member AB. So that is minus 5.06 and minus 5.06. And for the column, it's going to contribute 50%, or that's a minus 10.13. Okay. So to help reduce the confusion, I can say that I have balanced the moment. So I'm going to put the line here just to show that, okay, this is the end of my first cycle. Okay. And now we move on to joint A, where we have the unbalanced moment of minus 20.25. 40% is going to come from member AB, and that is 8.1. And this is 60%, so it is 12.15. Okay, and then we underline it. Underline, it's not even under. Okay. Okay, so that's the end of our first cycle. Okay, now the mess is going to begin a little bit when you do need to carry it over. But luckily, at least we have modified our simple end support, right? So I need to carry the moment. Now you guys need to be extremely concentrated, because you should know that this is 8.1 is at the end of member AB. So this will be carried over here, right? A half of that, 4.05. This will, oops. Oh, geez, sorry. This will be carried over here, right? It's the opposite. And that is minus 2.53. And what else we have? We have 5.06 that will be carried over here. That is also minus 2.53, right? And then this will be carried over to the opposite end as well. That is minus 5.06. Okay. Woo! So we are now ready to do the second cycle. Let's hope. Okay. Right. So you can see if you use different color, I have carry over the blue one, all the blue ones that can be carried over. This 12.5 will not be carried over because we have modified it. Oh, so that's the end of it, luckily. So now it's time to balance it, okay? Let's begin here, it looks easier. Now you have unbalanced moment of minus 2.53. So I'm gonna balance it. I need 2.53 and 40% is gonna come from this member. So this is 1.01 and another is 1.52 here. So that's the end of my second cycle. I'm gonna put 2 lines so that I know. And look like 2 lines, but yeah, believe me, that's 2 lines. And let's erase this a little bit so that you know that's 1 line, okay? Okay, that's the end of my second cycle, and you may want to check it as well. And now let's move on to the second cycle of the column on the right, that is column CF. We have minus 2.53 and the result is somewhat similar. Okay, so that's 1.01 for the B member. and then another 1.52. Okay, so that's the end of this cycle, which is the second cycle. It doesn't have anything on the first cycle, so I'm just going to use 2 lines here. Okay, so that's the end of that member. So now we move back to joint B, which we have unbalanced moment of 4.05, the red one. Now we have 3 members. So 25% is going to come from member AB. That is minus about 1.01. And then member BC, it's another 1.01. And then member BE, which is a column, that's 50%, so it's minus 2.03 exactly. Don't go crazy about the numbers, you know. So that's the end of the second cycle. All right, and maybe because the moment is not so low, we need to do another carryover. All right, so take a deep breath and carry on, soldier. So I need to carry which one over? This has to be carried to that, right? And this will be carried here. So let's have some number. It's minus 0.51 minus 0.51. This will be carried over here. Minus 0.51. And then this will be back there. 0.51. And then what else here, right? Minus 1 something. 1.02. And it's not a bad, you know, it's crooked. It's not a bad idea to try to, okay, give it, that's the end of the first cycle as well. Minus 1.02. Anywhere else? We have send this back here and send, okay, so then that's it, right? So you see, everything we do here, then it's not difficult, but it just, in English, we call it bookkeeping skill. You need to, you know, be able to follow every step with perfection. Okay, so we have carried the moment over. Don't forget to balance it again. Otherwise, your sigma moment will not be 0. So let us begin at joint A again. We have unbalanced moment of minus 0.51 here. 40% is going to come from this member AB. So that is about 0.2. Then that's the end of the third one. Third cycle. Let's draw 3 lines. And 60% is going to come from the column. That is 0.31. 1, 2, and 3. That's the first column. And then the second column, we have unbalanced moment of minus 0.51. And 40% is, again, about 0.2. And 1, 2, 3. And that's 0.31. 1, 2, and 3. Now in the middle joint, you have to be a little bit careful because you now have 0.51 coming in from joint A and another 0.51 coming in. So, now what is what? Oh, that's a positive one. Okay, this is the glitch from writing. Okay, because that's 1.01. So here is, oops, that's 0.51. So you have two 0.51s coming in. So be careful. You need to add them up, from the moment from every direction. So you have unbalanced moment of 1.02. So here it's going to be minus 0.255. It's the end of the third cycle. And here is 25%. So it's the same, minus 255. And here is about minus 0.51. Okay, and just that's it. That's the end of the third cycle, and it would be nice to send this to the fixed support a little bit at the end of the third cycle as well, and that's minus 0.26. Okay, so I hope the moment is small enough. So I'm gonna summarize by using a different color. Okay, here at the end of member AD at joint A, this is 13.98. Okay, right there at the AB, that's minus 13.98. See that? Same number. Right here at the end of member AB on B side, we have 18.49. Next is that minus 5.82. And right here on the column BE, that's oh, I can't read my handwriting. So let's okay, it's minus 12.67. Okay, now you sum them up, minus 12 and minus 5.82, that should be equal to 18.49. Okay, so back to the end of member BC, that's minus 1.83, and this is 1.83. Okay, so that is the end of our first category of moment distribution. Okay, after you do this, you should know that this is a sideway problem. Okay, and this is moment due to the let's say fixed end moment alone. Okay, this does not include the moment due to sideway. So you can say it's the first one, the category A. You can say that this is, that doesn't look like an A. Let me try again. A. This is the moment due to the load. Okay, side sway not included. So what we need to do now is just we need to break down this into the free body diagram and solve it for our base shear. Okay, it is the shear of the member, but when it is a shear at the support of your building, many times engineers call that the base shear, the shear at the base. Okay, so this free body diagram, and be very mindful of your sign convention. Okay, I have seen only one, say, unusual sign convention in the homework. I don't know if she's around here. I don't see her, but please if you try something strange, you get strange results, and you get a strange feeling, and then that strange feeling may lead to, is it correct, or something like that, and then you may make the error upon yourself because you begin to feel strange. So right here we got 13.98, which is positive, so that means clockwise. Right, 1398. So you're gonna get this base here, and then the second one, you should look at this result, minus 12.67. So it's in this direction, right? So your shear is in this direction, this one, and then the last column, it's 0.6, right? So it's this one. So it's clockwise of 1.83. So the shear is this. Okay, we need to do this extra step, and that is 2.8. That is 3.17, and that is 0.52. So when I put this back into our frame, actually the legs are not equal, right? So let's make it different here. So you should notice that your sigma fx is not 0, and it should never be, because this result does not include the side sway effect. And so we have the unbalanced sigma fx of 0.50. So in other words, I should add the joint here to prevent the side sway, and I will get the reaction equal to 0.15. Okay, so you can say that this is your imaginary load for side sway. All right. So now our next step is to find the moment caused by this load. But again, we would never be able to do the direct calculation. We need to start by making assumption and then readjust our results to match with the load we want. Okay, so now here's the trick part. When you look at this frame, okay, let's say, do you think it is getting too long? Do you need a break before I start the second session? I mean the second category of the load? Or would you be okay if I include it in one clip? Hello? Hello, anyone?
In one clip.
In one clip? Fine.
For me.
Okay. You're the only one who speaks, so that should count. Okay. And let's say the next step, I am losing count. So let's say I'm gonna go back to this, and I may call this reactions. Okay. Okay. Oops. Use the back one. This is the reactions. Okay. And we are going back to this. Okay. Now It's a third step of the category B, okay? Fixed end moment due to side sway. Okay, now you go back to this frame, and you know that I can use a different color. Let's use the blue one, okay? And that's fine. You know that when the side sway is going to occur, actually your deflected shape should look like this, and then this, and then this. Your unknown is 1 delta, right? They all sway with delta. That's delta, that's delta, and that is also delta. But this time, your psi will not be 0. Okay? This is the psi. That angle. And this becomes the psi. Okay, I can call that psi AD. This is psi BE. And then that's the psi CF. So if you don't find the relationship between the fixed end moment under the same horizontal displacement, you are pretty much doomed, because it's true that we're going to begin by making assumption, but your assumption must have relationship. If you assume the fixed end moment for member AD, it must have some relationship with the fixed end moment of member BE and CF due to the fact that they have the same horizontal displacement. But you should know that the size is different. Okay, so let's move back here. Oh, here we go again. I changed that without changing. This is why we should use the good note, right? So the formula for fixed end moment is 6 EI delta over L squared. But I can arrange this so that by using, K is equal to I over L, right? So I move 1 L to be with I. So I have 6 EK and then delta over L, right? So now, this is for the fixed. When you have the fixed support, let's say you have 2 fixed end moment, right? But for the simple end support, it's a simple end like that. You can say you have 1, so you can use FEM equal to 3EK delta over L for the simple end support. Okay, so we have 1.5K and then the 2K, right? For member AD and CF, we have 1.5 I, and then the CF we have 1.5, and in BE we have 2 I. So we can now calculate the fixed end moment. Let's assume three E delta equal to 105. I don't know why I got that number. It must have been done a long time ago. So FEM AD, okay, it is because everything, let's assume that it goes to the right, and your frame, say, your frame will sway clockwise. You see that? Your columns going clockwise, so your fixed moment should be counterclockwise. So AD is going to be equal to minus 3E hang on a minute. Oh, okay. Sorry. For this is for simple support, it should be 3. I said 3, but I wrote 6. Oh, horrible. Okay. So it becomes minus 3E K delta over L. Okay. And this because I say 3E delta is 305, so that becomes minus 105 over the length 5, or minus 21 ton meter. Okay. For member BE, now you have FEMBE equals FEMEB. Now you have 2, okay? It's gonna be six E K delta over L which is equal to minus 2 multiplied by minus 105 and then divided by the length, which is 6. Okay. You know what? Be careful with this, because I believe after we use this for the simple n, the k here should be the original k. So that's why they are equal. Okay. So right here I got minus 35 ton meter, and then the last one FEM CF. Okay. That is also minus 3E K delta over L, and that is minus 105 over 3.5. That is minus 30 ton meter. So these are the numbers that we should begin our moment distribution. Okay, so we can just assume one number here, and the rest will have to be calculated with the relationship. Okay, you start off by saying this, and then the rest must be calculated accordingly. We have the same delta, and apparently if you look at because I decided to use this formula for the simple n, so I don't modify the k, it's the original k, okay, which is the equal. So okay, that's the numbers that we are going to have to begin our analysis with. So let me swap back to this. Good note, and that's the end of the first page. Because I have done one distribution for you, so it may not be a good idea to do another, and just to keep the time within the limit of 50 minutes. So let me try to be very quick with this. Okay. Because the procedure is going to be the same, you know. You only need to know that let's write down the distribution factor here as well, 0.6 and then 0.4, a quarter here, a quarter here, and then 0.5 here. 0.4 and then 0.6. Remember that this is the trial for the sideway, so your fixed end moment will be only with the columns, right? Your beams do not have the sideway issue, so that is minus 21. That is minus 35. This is minus 35. And that is minus 30. Okay, so we do the moment distribution as usual. Let's say, let's demonstrate it for one cycle, okay? Say you have minus 35 here. We're gonna balance that. 50% is gonna come from the column, so that's 17.5, okay? And okay, that's 8. I can't read my handwriting. 8.75, 8.75 here. And then for the column on the left, it's minus 21. So you balance it with 12.6 and 8.4 here. That's equal to 21, I suppose. And right here, minus 30. Then the balance it with 60%, that's 18 here and 12 there. So that's the end of the first cycle. And you again do the carryover. Okay, so this goes there. $4.38, and this comes here, and that's 4.2, and then this goes there, 8.75. That's the end of it, and this one comes in here. How do I write it? Hang on. Okay. 6.0. This one comes in here. Oh, it's on top, right? Oh, I thought it was going to write it at the bottom. That's fine. You know what? Let's be consistent. So one moment. It has to be 12 here, right? Okay. 6 is gonna come from that, and then for 8.25, half of that will be 4.38. Okay. Gotta add a line to end the cycle here as well. Okay, so you balance another round. All right. Let me just do it for you, okay? Because you may be curious a little bit. So we have 4.38 on the left column. We're gonna need to balance that. And we have to have minus 1.75 here. That's the end of the second cycle for this. And then minus 2.62. Okay. And for the column on the right, you got 4.38 coming in. So 40%, that's a minus 1.75. 2 lines. And then 60%, it's minus 2.62. Okay. And for the column in the middle, we got 6 coming in and we got 4.2 coming in. So that's 10.2. 50% of that is minus 5.1. And then, divided by 2, it's about 2.25. And then another 2.25. Okay. And one more round. You can go one more round. 2.25 goes back up.
Is that 2.55?
Yes, 2.55. I said 35.
You said 25.
Right. Sorry. I'm sorry. Just got, my tongue is tired a little bit. Sorry. Okay. Yeah, it's 2.55. And then minus 1.75 is coming back here. Okay. So let's write the number. The 2.55, go back there, that should be minus 1.28. That means you guys are listening. Thanks a lot. That's minus 0.88. Okay, let's send this over here. Minus point, that means minus 2.55. And then what do we need to send over? We got this. So this comes back here. Yeah, hang on a minute. That's minus 1.28. This goes up. 1.75 goes up. That's a minus 0.88. Okay. So then that's it. Balance it one more time, guys. I need to do this so that you're not gonna say, actually the instructor has never done it. You just say, okay, you keep doing this. Then he can't do it. Actually, I can. Okay. All right. So we have 1.28 unbalanced moment on the left. So you got 40% of that. That's 0.51. It's the end of third cycle. And then that's 60% of minus of 1.28. That's about 0.77. 1, 2, 3, third cycle. And on the right, we have minus 1.28. So what we need 1.28 of that. 40%, that's 0.51. And then 60%, again, it's 0.77. And in the middle, we have 2 minus 0.88 coming in. So 25% of that, that's 0.44. 3 lines, that's another 0.44. 3 lines, oops. It's getting ugly now. And, that one, that's going to be quite something. That's 0.88 right there in the hairline. Okay. And I just carry this once more to increase the fixed moment. That's 0.44. So that should do it. Woo. Okay, so let's sum it up. Here is minus 10.25. That is 10.25. Actually, it's 10.26, but you know, it's okay, right? That's 9.96. That's 11.76. That's minus 21.72. Right there is, okay, let's do it here first. Minus 28.36. Here is 13.86. And that's minus 13.85 actually, but that's fine. Okay. So again, now we have finished our moment distribution, and we do the same. Okay. We bring this moment and calculate the base shear. Okay. Just let's say what I did with this. Okay. Right. So here, oops, should use the black one, right? Be consistent with the previous work. You got this, you got the negative moment, which means it's counterclockwise. So your shear is in this direction. Okay. Oops, sorry. I am confused too sometimes. In this direction. That's 2.05. Coming from the moment of 10.25, right? Yeah. The second one, the moment is, where is it? That's minus 21.72. It's minus, so it's counterclockwise. And the shear is in this direction again. That's 8.35. Oops, forgot that. We need to have this too. 28.36. So that, but the number is this, the answer is the same, 8.35. And the last one, you know, okay, this one. Again, counterclockwise, 13. Oh, sorry. Be consistent so that you guys can have something better to look at. 13.86. And the moment is therefore giving us the shear to the left. That's 3.96. So from this, I get the total shear. It was as if this frame is being pushed by the total load of, you know, if that's 2.05, that's 8.35, and that's 3.96. This total is 14.36. But your target is to find the frame that is pushed by 0.15, right? I draw this as a reaction, but it's the same thing if I draw it there. You know, so your target is 0.15, but after the trial, I give you 14.36. So that means, say if I should change it, okay. So let's say target is 0.15, but instead moment due to, oh, what's this? 14.36 tons is obtained. So we need to go back and therefore the this is the our step B, right? We call this A somewhere. Yeah, okay, A. So this is called B, right? Due to sideway. That's this is the name. Okay, it doesn't matter. Therefore, we need to modify moment in step B by, because we want 0.15, right? It has to be 0.15 over 14.36. Okay. And after this, your structure is going to be the summation of the end moment will be equal to okay, it was fine. So the answers will be moment in case A plus moment in case B, that is multiplied by 0.15 over 14.36. That will be your final answer. Okay, since if you want to see it, I can do it for you, but it's been almost an hour now and I'm afraid that the clip is going to be too long. So I think you get the idea. So to add the first case with the second case, it shouldn't be any problem, right? You need to come back and modify all these end moments by that factor, which is 0.15 over 14.36. Okay? And then add up with the moment due to case A, which is this. And then you have your final answer. All right? So I'm just gonna stop the share right away and stop the record as well.